Here is the simulation of our project. Here the two potentiometer is used. First one potentiometer is used to simulate the potential of the battery, and the second potentiometer is used to simulate the charging and discharging current. So first, whenever the battery is discharged, that is have low voltage, in the right side of this display, here shows all the vital parameters of the EV. That is, first one is voltage, second one is current, third one is temperature, fourth one is humidity, then SOC. SOC means the state of charge, and then cycles per second. Okay. So, and the last one is the health. So, whenever we change the potentiometer, the battery voltage got increased. That means the charging starts. As in the right side, you can see the charging starts to 5.2 volts. So it will detect as a low voltage. As below 12.5, it is low voltage. So when the battery starts charging, it continue to go up, and at a time when the voltage reach 12 volt, that is more than 12 volt. Here 16.25 volt is giving. So then the alert is removed. Here only two alert is given for humidity. The heat can be changed from here. That is below 45 degree, it is normal temperature, and below 90% humidity, it is normal humidity. Above these both two humidity, alert will be given. So this will give an alert whether the condition where the battery is kept is perfect or not. Because whenever the humidity got rises, there may be some possibilities of short circuit. Here we have used the two displays, that is the TFT displays. To right one is for only parameters and left one is for the alert. Then whenever rash driving occurs, like for the rash driving, the battery life will affect. Then we here simulate the rash driving by the accelerometer. Whenever the x-axis and y-axis changes, that means drifting occurs. In the xy plane, the drifting occurs. Then here the alert occurs, that is rash driving. So this rash driving will affect the state of charge as well as the health. So the health decreased to 99.9% here. So basically here the microcontroller used is ESP32 that will generate all the possible signals and compute all the computation. Here DAC22 is the humidity and temperature sensor, and the two alert is given. Whenever the battery usage is high, then in that case the current usage is also high. So we simulate this current usage by changing this potentiometer. Like you can see, here the current increases to 19.4 amps. Here the high battery usage will pop up, like here, high battery usage. So this will create a notification to the driver. At that time, we can change our speed and can maintain our battery life to longer. So this is our program, and now I'm going to describe about the flow chart. So here is our flow chart. At first, the inputs is taken in the ESP32 pin 27, that is the humidity pin, means the humidity sensor output. Then the potentiometer is simulating the voltage and current. Then the output is given here in the TFT display. There will be condition checking, all the condition checking that I have discussed earlier, that whether humidity is high, whether temperature is high, whether the rash driving occurring or not. All these things will got checked by the microprocessing unit, and then the current and voltage behavior will be measured. For harsh braking, the voltage suddenly drop down below 12.5 volt. At that time, it will detect the harsh braking. So harsh braking also impact on the battery voltage and battery life. Then the cycle detection, that is the cycle detection actually occurs between the one cycle when the battery, that is the state of charge, goes below 60% but above 40%. That state of charge is measured, and all alerts will be given on the TFT display. If no alert is given, then the behavior is appropriate. That is, the system is functioning well. So this will update with after every 2 seconds. So this is our project, and so The technology that we have used here is the hardware part. We have used the ESP32 and DHT22 sensor. Here the DHT22 sensor is the temperature and humidity sensor. Then the TFT displays. The TFT1 display shows the real-time parameters, and the TFT2 display will show the low voltage, overheating, high humidity, rash driving, etc. alert sensing. So this potentiometer 2 is used for voltage and current source to demonstrate the charging and discharging of the real battery. And for demonstration purpose, we have used the software OAK simulator and Arduino IDE. So in the next slide, we have given the challenges and solutions. So basic challenges that we faced while building this project is that accuracy, limited accuracy, and cannot capture the real-time battery behavior as no battery is present in the simulator. So there is a problem that in the practical field how this battery will behave. Then no remote monitoring, data only on TFT and no cloud app is giving. Then EEPROM logging, that is the limited write cycle, small memory, SD card module, adds slight extra cost. Then the voltage based on SOC estimation, linear mapping and inaccurate in real EVs, requires additional circuitry and medium cost. That is basically the cost increases with certain circuitry. Scalability to real EV packs. Prototype monitor single source, not suitable for multi-cell pack. Higher cost and BMS chip required. So the solution is that if we use the dedicated current sensors and voltage sensors, then temperature sensor can be replaced by thermistor or DS18B20 module. And then if we use a GSM for alert and or MQTT for Wi-Fi to connect it with the cloud app, use FRAM or SD card for data history for better usage pattern and monitoring. We can add also a Coulomb counting or BMS algorithm, and multi-cell monitor ICs can burst. So with this, we are concluding our project. Thank you.